Okay, welcome back. This time we want to deal with graphing these characters, and I kind of have. Okay, yeah, I'll just get at it. So 11.3 quadratic functions. And their graphs. Okay, and we'll kind of have a method for how we want to go about doing these. There's two basic versions that formulas that you're presented with, sort of forms for the functions that you're presented with. So let's take a look. So the quadratic function and the graph. So we're no longer working just with equations of lines and graphing straight lines. Now we'll have these horseshoe-shaped things. So let me give you a picture of what I'm talking about. It kind of looks like a U. Okay? There'll be this axis of symmetry, which is not part of the graph. It's just kind of a, I don't know, an aid in graphing. And basically what the axis of symmetry does is cut it into two parts, such that this half and this half are exactly the same. And basically you took this paper and folded it and then shaded it down. You would have the same thing over here. So this side and this side are exactly the same. And that line is called the axis of symmetry. Okay? Axis of symmetry. Okay. The axis of symmetry goes through this point on the graph called the vertex. And in this orientation, it's the lowest point on the graph. Okay, so this is the vertex. So that's one version. The other version is when it's upside down. Okay, so it'll look like this. Here's its axis of symmetry. And again, it's going through the vertex of the graph. So we call it a parabola, but there's the vertex. The vertex is usually given the point h comma k. So you don't want to say x, y because it's confusing, so we just use the letters h and k. All right. So the two forms that we deal with, the first one is the one that's familiar to you, y equals ax squared plus bx plus c. And you could tell which graph you have just by looking at the leading coefficient, the a value. If a is positive, you have this shape. Okay. So some math people call it concave up. I usually call it smiley face because it looks like a big smiley face. If a is negative, you have concave down, which is usually I'll call it sad face. Okay. Okay. The other form is y equals a times x minus h squared plus k. If you FOIL this out, you'll just get this form here. Okay? The a value works the same way as it does over here. The benefit of this form is you're automatically able to see what the vertex is just by looking at it. Okay, so the vertex is going to be h comma k. Over here, that's not the same deal, but you can still get the vertex if you do a little bit of work. And we have a vertex formula. Okay, so the vertex over here is going to be negative b all over 2a, comma, and then you just take the x-coordinate and put it into your formula to get the y-coordinate. So to notate that, I'll write f of negative b over 2a. Okay. Okay, so we'll begin playing around with this guy here, this form. Okay, and the way we'll do it is first determine the shape. So if A is greater than 0, then you have a happy face. If A is less than 0, then you have a sad face. Secondly, then you'll find the vertex. And then thirdly, you'll get the x and y intercepts. So this last part is pretty easy. We've done it before with equations of lines. For the x-intercept, you let y as 0. For the y-intercept, you let x be 0. So it's pretty simple. All right, then, let's try number 10. So we have f of x is negative 3 times x minus 2 squared plus 12. Okay, so first, the a value is negative 3. That means we have a sad face. Secondly, the vertex, it's going to be the same as this, comma this. Okay. Sometimes you have to worry about the signs. If this had been x plus 2, your x coordinate would have been negative 2. If this had been minus 12, your y coordinate would have been minus 12. Okay. So you have to be a little careful with the signs. In this case, you just take it as is, 2 comma 12. Then we want the x-intercept and the y-intercept. So for the x-intercept, you let y equal 0. Okay, so we'll have 0 equals negative 3 times x minus 2 squared plus 12. And this should look familiar to the work we've been doing. Okay, so it's ultimately an application of our previous work. I can isolate this radical term, or the square term, excuse me. So I'm going to move the 12 over. And divide by negative 3. Negative 12 divided by negative 3 is positive 4. And then do the square root property on both sides. So x minus 2 is plus or minus square root of 4. Square root of 4 is 2. And then add 2 to both sides. So x is 2 plus 2, which is 4. Or x is 2 minus 2, which is 0. So these are x-intercepts, the place where the graph is going to hit the x-axis. Okay. So your coordinates will be 4 comma 0. The other coordinate of the x-intercept is 0 comma 0. Whoop. Let's look at the y-intercept then. For the y-intercept, you let x equal 0. Okay, so I plug 0 into this formula. I get y, and you could use y instead of f of x. So y is negative 3 times 0 minus 2 squared plus 12. And then you just do your PEMDAS. So please excuse my dear Aunt Sally. Negative 3 times 0 minus 2 is minus 2 squared plus 12. So I did parentheses first, then exponents. Negative 3 times negative 2 squared is 4. That's 12. Negative 3 times 4 is negative 12. And so we're getting 0. So the y-intercept is 0, 0. You see, well, that's the same as one of the x-intercepts. Oh, yeah. Okay, the last step then is to take all this information and put it in your graph. So I need a lot of room in, looks like the first quadrant to get to the vertex, which is at 212. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so 212. 1, 2, one of the rest, 12. 4, 0. 1, 2, 3, 4, 0. And then 0, 0. And then we know it's a sad face. So connecting the dots, it looks like it's going to go like this. Lastly, then you could talk about the domain and range. So the book may ask you for that information. And the domain will always be negative infinity to infinity. So that's easy. That turns out to be the domain for any polynomial. So anything that is of the form ax to some power, like ax to the fifth plus bx to the fourth, anything like that, a polynomial, a line, the equation of a line is a polynomial, and its domain is also negative infinity to infinity. The range is just basically going from the bottom to the top, or vice versa. So this thing, it doesn't really, it's going on and on, down, 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 down forever. So it's in the downward direction, it's going to negative infinity. In the upwards direction, though, it has a cap on it, right? So it'll stop at this maximum height, which is at you can tell where it is from the vertex, right? It's the y coordinate of the vertex, so it's 12. Right? And in general, you could play that game with range. For the range, there are two cases. Either you have the downward shape, and here is our vertex at h comma k. The range in this case, of course, the domain is negative infinity to infinity, but the range will go negative infinity all the way to the top, which is at k, and you include the top part. When it's a happy face shape and the vertex is on the bottom, then the range, well, it goes from the bottom, which is k, and then it just keeps going up and up and up and up and up. So it'll go to infinity. Okay. So those are the two basic cases, and you get the k value from the vertex. It's the y coordinate of the vertex. Okay, let's look at 22. We have y minus 3 is x minus 1 squared. So first thing, we want to put it into our form. When it's in this form, you can immediately just take the opposite signs to get the vertex. Okay, the vertex will be not negative 1, but positive 1, and the y coordinate will be 3. Okay? But let's put it into its form. Y is x minus 1 squared plus 3, and then go through our steps. So first step, the a value, whatever's in front of this thing. If you don't see anything, you just always assume it's a 1. Right? So our a value is 1. That's greater than 0, so that tells us it's a happy face. Okay, this is my little arrow. It tells us this. Step 2, I need my vertex. I could just read that off. Like I was saying, it's 1, 3. Finally, my x and y intercepts. For the x intercept, you let y equal 0. Okay, so we'll have 0 is x minus 1 squared plus 3, and then solve for x. Okay, so subtract 3 to both sides. Square root property says x minus 1 is plus or minus square root of negative 3. And we have a problem here. We can't, in the xy plane, you're not going to be able to draw these imaginary solutions. And this is an imaginary solution, negative 1, positive 1 plus or minus the square root of 3i. Okay? So that just means there's no x-intercept. And that happens when the parabola doesn't touch the x-axis. So we can predict our parabola will look something like this. Okay? So it doesn't hit the x-axis. It doesn't go through it. Okay? Then we want the y-intercept. So for the y-intercept, you let x equals 0. We'll have y is 0 minus 1 squared plus 3. So that'll equal negative 1 squared plus 3. Negative 1 squared is 1 plus 3 is 4. So our y-intercept is, we let x be 0, and then y is 4. Okay. So then I go ahead and plot it. So the vertex is 1, 3. Whoops. The y-intercept is 0, don't move, and then go up 4, 1, 2, 3, 4. I know it's a happy face. The axis of symmetry would be through the vertex, okay? And its equation is just x equals whatever the x coordinate of the vertex is. So it would be x equals 1. So one side of the parabola must look like this, and because of the axis of symmetry, the other side looks exactly the same. And so we can go ahead and draw that. And then the domain, of course, is always the same. It's negative infinity to infinity. And the range this time, it starts from the bottom at the k value, whatever that is, 3. Right? You just borrow it from the vertex. And then it just goes up and up and up and up and up. So it goes to infinity in the top direction. Let's look at one more, and then we'll go to the other form. So number 24, we have some fractions. F of x equals 5/4 minus x minus 1/2 squared. Okay. So first, I'm just going to rewrite it a little bit so it's in the standard form. It's minus x minus 1/2 squared plus 5/4. Okay, so first off, the a value is this part, the -1. So that means it's less than 0, and that tells me it's a sad face. Secondly, I get my vertex. So it'll be 1/2, comma, 1/2, comma 5/4. And if you want to get a decimal for that, that helps you to draw it. I'm not going to bother. X intercept then, that you let y equal 0. Okay, so we'll have 0 equals negative x minus 1/2 squared plus 5/4. I'm going to move this stuff to the other side, so I have x minus 1/2 squared equals 5/4. Square root property says x minus 1/2 is plus or minus square root of 5/4. The square root of 4 is 2, so this will just end up being square root of 5 all over 2. Then I'll add 1/2 to both sides, so x equals 1/2 plus radical 5 over 2, or x equals 1/2 minus radical 5 over 2. And I'm splitting them up because I'm going to go to my calculator now and get some approximations. Okay, beep, 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 beep. And I found the first one was 1.62, about. And I found the second one was negative 0.62. So that'll help me graph it if I get some approximations. For your y-intercept, you're letting x equal 0, so I'll have y is negative 0 minus 1/2 squared plus 5/4. Right. Order of operations, do parentheses first, so negative 1/2 squared plus 5/4. And then I have negative 1/4 plus 5/4, which of course is 4/4, which is 1. So my y-intercept is going to be at 0, 1. And I can go ahead and plot it. The vertex, let's get some tick marks. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So my vertex is 1/2, and then 5/4 is about right here. The y-intercept is 0, 1. It's about right there. My x-intercept's 1.6 something, and then negative 0.6 something, about right there. connect the dots. There's my vertex right there. The domain, of course, is always negative infinity to infinity, and then the range. In the bottom direction, it's going down, 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 so negative infinity. In the top, it'll have a maximum here at the y-coordinate of the vertex, which is 5/4. Just take that and borrow it, put it there, and you include that top point. Okay, so that's the first form of the quadratic that we saw. Okay, so there's going to be two formulas that we use. We just did this formula. Now we want to do this formula. And getting the vertex is a little bit more work. So this is the form f of x is ax squared plus bx plus c. The new thing now is then the vertex, you have to use the formula negative b over 2a comma f of negative b over 2a. The process is the same though. We're going to identify as happy or sad, then get the vertex, then get our x and y intercepts, then graph it, and then identify the domain and range. Okay? So let's look. Here's 28. I have f of x is x squared minus 2x minus 15. Okay. So first off, the a value. The a value in this case is whatever's in front of the x squared. If you don't see anything, it's just 1. So it's a is 1. That's greater than 0. That means we have a happy face. Secondly, get the vertex. So the x-coordinate, which I'll call h, is negative b. So negative 2 all over 2 times a. Negative 2 is positive 2. 2 times 1 is 2. 2 over 2 is 1. Then you just take this and put it back into the original function. So it's like when you're doing a table of values. You know, if you had 1, how would you get the y value? Well, you would go back to the original formula and plug it in. That's what we're doing here. Okay, so the y value, which we call k, will be 1 squared minus 2 times 1 minus the 15. Okay, so literally it's this equation is where I go. And then 1 squared is 1, minus 2 times 1 is 2, minus 15. 1 minus 2 is negative 1, minus 15 is negative 16. Okay, so our vertex is 1 comma negative 16. Okay. Step 3 then, the x and y intercepts. For the x intercept, you let y equal 0. Okay. So I have 0 is x squared minus 2x minus 15. And here, you hope you can factor it, of course, but sometimes you have to use a quadratic, which is sad, but it's just the way things are. So you try to factor it. It has to be plus minus. Oh, and this one works. So the big one's 5, the little one's 3. Okay. Then set each part equal to 0. So either x is negative 3 or x is positive 5. So our x-intercepts will be negative 3, 0, or, and, sorry, 5 comma 0. Y-intercept then, you let x equal 0, so you'll have y equals 0 squared minus 2 times 0 minus 15. 0 squared is 0. 2 times 0 is 0, so you have 0 minus 0 is 0, and then minus 15. So it'll always just turn out to be the last number in your function. So anyways, 0, negative 15. Finally, we take all of our information. We're going to have a lot of room in the third and fourth quadrants because of our vertex. 16. And then we have probably 5 in the x direction. Okay, so my vertex is at 1, -16 is right here. My y-intercept at 0, -15, which is there. And then my x-intercept's -3, 0, and 5, 0. And then just connect the dots. Make sure it's smooth on the bottom. Okay, so you don't want a corner. That'll be a different kind of function. And then we go for the domain and range. So the domain's always -infinity to infinity. And then the range this time, it starts, the bottom part, the minimum value is going to be -16. And that's with a bracket. And that just keeps going up and up and up and up. So -16 to infinity. All right, let's look at another one. So 34. So I have f of x is x squared plus 4x minus 1. So first, the a value is 1. It's greater than 0, so it's a happy face. Get the vertex. So the vertex, the x-coordinate, h, is -b, so -4 all over 2 times a. So -4 over 2 is -2. The y-coordinate, then, you plug this back into the function, so you get -2 squared plus 4 times -2 minus 1. -2 squared is 4, minus 8 minus 1. So -9 plus 4 is -5. Okay, so our vertex apparently is -2, -5. Then I need to track down the x-intercept. For the x-intercept, you let y equal 0. So 0 is x squared plus 4x minus 1. Okay, you can try to factor it, but it's not going to work. So you're going to have to go to a quadratic. X is -b minus 4 plus or minus the square root of b squared, so 16 minus 4 times a times c, all over 2 times a. So it'll be -4 plus or minus the square root of 16 plus 4, all over 2. That'll be -4 plus or minus square root 20, all over 2. Then we want to march out perfect squares. So it's -4 plus or minus 4 radical 4 times 5, which is 2 radical 5, over 2. Factor the numerator, so you could factor a 2, and you get -2 plus or minus radical 5, all over 2. And the 2's will cancel, and you're just left with x being -2 plus radical 5, or x equals -2 minus radical 5. And I'm writing them separately again so I can get those approximations. So -2 plus radical 5 is about 0.24. -2 minus radical 5 is about -4.24. Okay, so I'll zip over and graph this guy. It's vertex, -2, -5. X-intercepts 0.24, it's about right here, and then -1, 2, 3, 4.24. The y-intercept was, oh, I never got the y-intercept, but that's easy. The y-intercept will always just be the last number. So find the y-intercept, you let x be 0, so y is 0 squared plus 4 times 0, which is 0 minus 1. So the y-intercept is 0, negative 1, which is just right here. Okay. Connect the dots, make it a smooth curve. And so our domain, as usual, negative infinity to infinity, and our range, we start at the bottom this time at negative 5, and then you just keep going up and up and up and up. Okay, so to infinity. One second. Okay, sorry. One neat thing about parabolas is you can kind of see the top and the bottoms, you know, the max and the min on these things. Okay, so if you have the happy face, it's going to have a minimum value. So it'll have a min at the y value, or sorry, at the x value. So the min will take place at the x value. So there's a min at x equals h. The min value is the y value. So whatever the k coordinate is, we saw it in the range, you know, that would be it'd go from k to infinity, right? So that would be a min value on the graph. When it's a sad face, then you have a maximum, right, at the vertex. So the max occurs at x equals h, and the actual max, the max value, is the y coordinate. Okay. Okay. So 40, they want you to find where they want you to find the min and the max and determine where it occurs, and then find the domain and range. Is it a min or a max? Find min or max and where it occurs. And then also find the domain and range. So that range is really based off of that actual min or max value. Okay, so here we have number 40. F of x is 2x squared minus 8x minus 3. The a value is 2, which tells me it's happy face, so we'll have a minimum value here at the vertex. So the h value, the location of the minimum value, is negative b all over 2 times a, so 8 over 4, which is 2. And then the y value, you take the 2 and plug it back into the formula. So you'll have 2 times 2 squared is 4, minus 8 times 2 minus 3. So you'll have 8 minus 16 minus 3. So negative 8 minus 3 is negative 11. So ultimately the minimum, the minimum is negative 11. The min value is negative 11, and it occurs when x equals 2. Okay. Then the domain, as usual, is negative infinity to infinity. And the range, we start from the bottom and then it goes up and up and up and up. So it starts at the min value, negative 11, and then it just keeps going up and up. Okay, so if you know how to find the min and max, you can solve a lot of applications. And one application here we'll look at has to do with throwing a ball. Section 5, applications. So it's number 57. We have a formula given, S of t equals negative 16t squared plus 64t plus 160. S of t tells you the height of the ball above the ground. So you're throwing a ball straight up, and or not straight up, but you know, you're throwing a ball, and S of t is telling you the height of the ball above the ground after t seconds. And the height is in feet. Okay. So let's see what they want to know. Part A, how long until the ball hits the max height, and what is the maximum height? Okay, so they're asking you for the maximum of this thing, and you know, if you look at the function, it's negative 16, so the a value is less than 0, so it's a sad face, so you do have a maximum here, and the maximum information is encoded in the vertex. So we need the vertex. H is negative b, so negative 64 all over 2 times a, which is negative 16. So I have negative 64 all over negative 32, which of course negative over negative is positive, and then it's just 2. Then plug that back in. So k is negative 16 times 2 squared is 4, plus 64 times 2 plus 160. So that's negative 64 plus 128 plus 160. And then that just equals 224. Okay. So the x-coordinate is where it occurs, and the k value, the y-coordinate, is how high it is, the maximum. Okay. So the max height occurs 2 seconds after they throw it. The maximum height is then 224 feet. Okay, let's see what else they have for us. Part B, when does the ball hit the ground? Okay, so what they're asking for is when is the height of the ball 0? Okay, so they're being clever, but that's all they really want to know. So when is S of t equal to 0? And really all that is just the x, in this case the t intercept. Okay, so you're going to set it equal to 0. 0 is negative 16t squared plus 64t plus 160. To make life easier, I'm going to multiply both sides by 1 over 60. Oh, sorry, 1 over 16. Let's make that a negative 1 over 16, right? So we'll have 0 is t squared minus 4t minus 10. We're not going to be able to factor that, sadly, so we'll have to go to our quadratic formula. So t is negative b, so negative 4 is 4, plus or minus square root of b squared is 16 minus 4 times a times c, all over 2a. 2 times 1 is 2. And then 4 plus or minus square root of 16 plus 40, all over 2, which equals 4 plus or minus 56, all over 2, square root of 56, all over 2. And I believe 4 goes in the 56, so we can march out a perfect square, leaving us with 2 radical 14 over 2. Then we can factor a 2 out of this expression. And then remove these 2's, and you get 2 plus or minus radical 14. Okay, there's going to be a positive answer and a negative answer. We want the positive one. Of course, we don't care about time that's negative. That wouldn't make any sense. So we'll get an approximation of about 5.74. Okay, so the ball will hit the ground 5 seconds after it's thrown. About 5 seconds after it is thrown. Okay? Okay, so I think that'll about do us for this section. And we'll see you next time.